Welcome to the second unit, Permutations and Combinations, and we would be introducing the basic concepts, the basic terminologies that we will be using in this chapter, and some fundamental principles that we need to define permutations and combinations. Before we go to the definitions of permutation and combinations, briefly, why we need permutations and combinations is because it provides a systematic structure to count. Basically, it will give us a tool in finding how many ways a particular process can happen, or how many ways, how many options do we have, or in how many ways a particular event can happen. So it will give us a systematic tool, in finding the number of ways, number of options that we have. It is a foundation to understand probability theory, and probability theory is itself a foundation to almost every research area that we have. It is also necessary to study various probability distributions used to model physical processes. Whenever we want to study a physical process, we usually transform that physical process into a mathematical model. And most of these mathematical models, they are in terms of the probability distribution. They use probability theory. So in a way, to go ahead with this mathematical modeling of any process, we need to have these foundations, the basics of permutations and combinations. It is also important and very important in Six Sigma problems. Now, the definition of permutation and combinations will depend on simple principles, fundamental principle of counting. And there are two simple principles. One we say is the rule of product. What it says is, if one event can happen in m ways and another event can happen in n ways, then both these events can happen in m into n ways. If one event can happen in m ways, another event can happen in n ways, both these events can simultaneously happen in m into n ways. This we say is the rule of product. The same way we have rule of sum. If one event can happen in m ways and another event can happen in n ways, then one of this event can happen in m plus n ways. So here in the rule of product, we are talking about both the events happening simultaneously. In rule of sum, we are talking about at least one of the event happening. So basically, when we say and, we multiply, and we say or, we add. So the basic idea is to know when to multiply and when to add. That is when this fundamental principle of counting will play its role. Let's say, for example, suppose you have 4 shirts and 3 trousers. How many different outfits can you make? So I have 4 shirts here and I have 3 trousers. Now, how many different outfits can you make? Or how many basically how many combinations can I make? So what I'll do is, I can wear this first shirt, blue shirt, with any of this trouser. If I wear it with the first trouser, then it will give me one outfit. If I wear it with the second trouser, I'll get another outfit. And if I wear it with the third trouser, I'll get another outfit. So this, depending on which trouser I wear this blue shirt, accordingly I have 3 options or 3 outfits. So every shirt here like this will give me 3 outfits. The second shirt also will give me 3 different outfits, depending on I'm wearing it with which of this trouser. So the first shirt will give me 3 outfits. The second shirt will also give me 3 outfits. Red shirt will also give me 3 outfits, and then black shirt will also give me 3 outfits, depending on which trouser we are. So each of these 4 shirts gives me 3 and 3 and 3, and so the total number of outfits that I have is 12. So the rule of product directly says, if this event can happen in m ways, that is 4 ways here, and this event can happen in n ways, that is 3 ways here, then both these can happen in 4 into 3, that is 12 ways. and that's how we get this 12. That's because each of these 4 shirts will give me 3, 3, 3, 3. These 4 shirts give me, each one of them will give me 3 outfits. That's why 4 into 3 equal to 12. So this is a typical example of the rule of product. If this can happen in 4 ways and this can happen in 3 ways, then both this can happen in 4 into 3, that is 12 ways. So the same way, let me consider this example here. A person wants to travel from Mumbai to Delhi. He has an option of going by train. 10 trains are available on that day, or a flight. He has 2 flights available on that day, or by bus. He has 10 buses available on that day. How many ways can he reach Delhi? Okay, so this person, for him to travel from Mumbai to Delhi, he has to take any one of this option. He can go by any of these 10 trains, or he can take any one of these 2 flights, or he can take any of these 10 buses. Okay, here we are stressing on or, while in the previous cases we had to have 1 shirt and 1 trouser. We used to say and. Now in this case he has to take only one of the options. So it is either this trains or flights or buses. So he can take any of these 10 trains, any one, or he can take any of the 2 flights, or he can take any of the 10 buses. So in total he has 10 plus 2 plus 10, that is equal to 22 options. 22 ways he can travel from Mumbai to Delhi. He can go by any of this 10 train, or, so moment we are saying or, we are adding or one of these 2 flights, or, that's why we are adding, or any of these 10 buses. So this is an example of rule of sum. So the basic idea about this principle of counting is to know when you should multiply and when you should add. Basically when we say and, we multiply, and when we say or, we add. The other thing that we need before we go to the definition of permutation and combination is a factorial notation. Okay, so we'll define factorial. For a positive integer n, the factorial of n is denoted by this notation. So we say n factorial this way. It is defined as n factorial equal to n into n minus 1 into n minus 2 and so on to 3 to 1. So given any positive integer, in fact this can be a non-negative integer because 0 will also be considered here. So if I consider any non-negative integer, n factorial is defined like this. Okay, let's say for example, if I have to write down 4 factorial. Okay, so this n is equal to 4. So start with 4, then into 4 minus 1, into 4 minus 2 till you reach 3 to 1. So this will be like 4 into 4 minus 1 into 4 minus 2 into 4 minus 3, okay, till you reach 1. Okay, so you have to directly write it as 4 into 3 into 2 into 1. So start with 4, deduct 1, then deduct 1, keep on deducting, subtracting 1 till you reach 1. If you multiply this, 4 into 3 into 2 into 1 is 24. So we say that 4 factorial or factorial of 4 is 24. The same way, suppose if I have to write down 9 factorial. 9 factorial will be 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So 9, subtract 1, subtract 1, subtract 1, subtract 1, keep on doing this till you reach 3 to 1 and multiply these numbers. If you multiply this number, this will come to 36 2880. Okay, it's a big number. 1 factorial will be straight away equal to 1 because that will be stop at 1 itself. So if I have to write down 3 factorial, what will be 3 factorial? 3 into 2 into 1, that will be 6. If I have to write down 6 factorial, 6 factorial will be 6 into 5 into 4 into 3 into 2 into 1. Okay, so multiply 6 into 5 and 4 into 3. If you multiply this number, this will come to 720. Okay, so this is how you define factorial of a number, and factorial in general is n into n minus 1 into n minus 2 and so on till 3 to 1. Okay. Another thing to note is 0 factorial is always equal to 1 by default. 1 factorial is also equal to 1. For any other number, we can use this definition in finding the factorial. So we have n factorial is equal to n into n minus 1 into n minus 2 by definitions. So if you recall, we have written 4 factorial is equal to 4 into 3 into 2 into 1. Now if you see, if I have to write down 3 factorial, what will be 3 factorial? 3 into 2 into 1. So you will see that in 4 factorial, inside 4 factorial, I have 3 into 2 into 1, which is actually 3 factorial. So this 4 factorial I can write down as 4 into this part is 3 factorial. Or we could have also written this as 4 into 3 factorial. Now 3 factorial is 3 into 2 into 1, right? So this is 4 factorial by definition. I could have also written this as 4 into 3 into, if you recall, 2 factorial is going to be 2 into 1. So this 2 into 1 is actually 2 factorial. So what we can do is, in this factorials, we can very well write down 4 factorial as 4 into 3 factorial, or this could be very well written as 4 into 3 into 2 factorial, or this can be written as 4 into 3 into 2 into 1 factorial. Okay, this we say is reduction formula. So like here, this n, if you just consider this n, and if you consider only this part, this is going to be n into n minus 1 factorial. Or if I consider n, if I just keep the first two terms as it is, n into n minus 1, then this part is going to be n minus 2 factorial. So like how I did it for 4 factorial. The same way, 4 factorial is like 4 into 4 minus 1, that is 3 factorial. Or I can write it as 4 into 3 into 4 minus 2, that is 2 factorial, what I did here. Okay, so in general, I can write down n factorial is equal to n into n minus 1 factorial. So depending on our need, either I can stop at n minus 1 and write it as factorial, or I can go on and I can write this as n into n minus 1 into n minus 2 factorial, depending on till how much you want to simplify it. Okay, so this is called as the reduction formula. Okay, now this reduction formula is going to be very helpful to us when we are simplifying factorials. Whenever we have expressions involving factorials, we will be using this factorial. Okay, let's say for example, suppose I want to compute the value of 8 factorial upon 4 factorial. If I have to go by direct definition, you will say it is equal to 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This divided by, so this is 8 factorial, and 4 factorial is 4 into 3 into 2 into 1. And then you will carry out these cancellations, you will find out the value. So if I use reduction formula, what I can do is I can directly simplify this 8 factorial till 4 factorial. I can write down 8 factorial as 8 into 7 into 6 into 5 into 4 factorial, because I have 4 factorial in the denominator, and this is 4 factorial as it is. I can straight away cancel 4 factorial with 4 factorial. I will be remain with only 8 into 7 into 6 into 5. That will come to 1680. So I don't have to write down like this each one of them or every factorial explicitly till 3 to 1, because I can use reduction formula. I can simplify the bigger number till the smaller number so that I can get rid of the smaller number. Let's say I have this 4 factorial into 9 factorial upon 6 factorial. So either I can write down 4 factorial explicitly, write down all the terms, 9 factorial and 6 factorial, and then carry out cancellations, or I can see that I have 6 factorial here in the denominator and I have 9 factorial here. So 9 factorial is bigger as compared to 6 factorial. So you can simplify this 9 factorial till 6 factorial. So what I'll do is I'll keep 4 factorial as it is. 9 factorial is 9 into 8 into 7 into till 6 factorial. I'll stop at 6 factorial because in the denominator I have 6 factorial. I did this so that I can cancel this 6 factorial with this 6 factorial. So this will be equal to 4 factorial is now 4 into 3 into 2 into 1. I cannot cancel more things. Everything is in the numerator. So now I'll write down 4 factorial and I have 9 into 8, 9 into 8 into 7. Okay. And if you multiply these numbers, this will come to 12,096. The same way, suppose I have say 10 factorial upon 7 factorial upon 4 factorial. How will you simplify this? I have 10 factorial here, I have 7 factorial, I have 4 factorial. So 10 factorial I can simplify till 7 factorial so that I can cancel it. So I'll write 10 factorial as 10 into 9 into 8 into 7 factorial divided by 7 factorial as it is. Okay. This 7 factorial will cancel with this 7 factorial, and this 4 factorial I'll write it as 4 into 3 into 2 into 1. Okay. 4 into 2 is 8, so this 8 will get cancelled, and I have 3 is the 9, so 10 into 3, 30. So the value of this expression is equal to 30. Let me consider this example. 11 factorial into 8 factorial upon 5 factorial into 14 factorial. Now which one are you going to simplify? I have 11 factorial, I have 14 factorial here. I have 8 factorial, 5 factorial. So probably we can simplify this 14 factorial till 11 factorial so that we can get rid of 11 factorial. And this 8 factorial you can simplify till 5 factorial. And the remaining numbers then you can multiply. So 11 factorial you will keep as it is because you want to cancel it when you simplify 14 factorial. 8 factorial you will simplify till 5 factorial. So 8 into 7 into 6 into 5 factorial divided by 5 factorial as it is. This 5 factorial will cancel with this 5 factorial, and this 14 factorial will simplify as 14 into 13 into 12 into 11 factorial. So that this 11 factorial cancels, 5 factorial cancels. Okay, and then we can carry out these cancellations. I have 6 2s are 12, 2 4s are 8. Okay, I have the 7 2s are 14, and I have 2 2s are 4, and so what remains is 2 upon 30. So value of this expression in terms of factorial is equal to 12 upon 30. So this is how this reduction formula is going to help you in finding the values of any expression that involves factorial like this.